Good evening.
Good evening, all of you. Please switch on your camera, everyone.
Good evening, ma'am.
Yeah, all of you, please switch on your camera. Okay, so we were discussing about the methods of preparation of alcohols. Okay, so I think we have discussed already. We have discussed the three methods, right? Like from alkenes, there are two methods, like acid catalyzed hydration reaction, and the second one is hydroboration oxidation reaction, right? And third reaction, we just discussed about the from haloalkanes how we can prepare the alcohol. Okay, so in haloalkanes, by the nucleophilic substitution reaction, which type of nucleophilic substitution reaction? So this follows this follows SN2 mechanism. Okay, by molecular nucleophilic substitution reaction. Okay, means a single step. So it's a single step reaction, means the attack of nucleophile and the formation of alcohol will take place in the single step, right? So that's how we just prepare the alcohol from the haloalkenes. Okay. So you are supposed to put the aqueous sodium hydroxide or potassium hydroxide. Okay. So from here, the OH group, OH minus will be released, right? And this acts as a nucleophile. So it attacks the alkyl group, which is positive. And from here, because the X group halogens are good living group, so you just left the bond and you will get corresponding alcohol. Okay, so that's the whole mechanism of this reaction. Okay, from haloalkanes, how we can prepare the alcohol. Now, the next method is again very important from carbonyl compounds. So, how we can prepare the alcohol by carbonyl compounds. Now, you all know very well what is carbonyl compound. So, the compound which contains this CO bond, right? This CO, like your ketone, okay, or your aldehyde, which is CH, this group, right? So basically, aldehyde and ketones, they are known as your carbonyl compounds. जिसमें carbonyl group present होता है, that is, you know, that type of compound is known as carbonyl compound. Okay, so aldehyde and ketones. So how we can prepare the corresponding alcohol by aldehyde and ketones? Okay, so this reaction is all about that. Okay, so first method, by the reduction of aldehyde and ketones. By the reduction of, when you reduce the aldehyde and ketones, so you will get alcohol. Okay, you will get alcohol. And you know very well what is reduction. Reduction is the addition of hydrogen or the removal of oxygen. That's the reduction, right? So what we are supposed to do, see, this is a ketone, CO group, right? This is a CO group. So suppose if we reduce this, we just add the reducing agent here, like a strongest there, like lithium aluminum hydride, like sodium borohydride, right? Like LiAlH4, which is your lithium aluminum hydride, and what is NaBH4? So it's sodium borohydride, right? So these are a reducing agent. Lithium aluminum hydride is a strong reducing agent. It will reduce each and every group. Okay, either it's a ester, aldehyde, or carboxylic acid, any group. So it will reduce it to corresponding different groups. Okay, and the sodium borohydride, it's not as strong as the lithium aluminum hydride. Just remember that. Okay, sodium borohydride is not as strong as lithium aluminum hydride. So sodium aluminum hydride, this will reduce only carbonyl compounds. This will reduce only carbonyl compound को ही reduce करता है, right? Which is aldehyde and ketone to the corresponding alcohol. Got my point?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay, so let's see how. Suppose we just add the reducing agent, any reducing agent like lithium aluminum hydride or sodium borohydride, right? So because sodium borohydride already it also reduce the carbonyl compound, so it will reduce this CO group. Now what you're supposed to do, because what is reduction? So reduction is the addition of hydrogen. तो आपने क्या करना है इसमें हाइड्रोजन को ऐड करा देना, right? So this is a CO bond. See, this is your carbon and oxygen bond. So what will happen? This bond will be break, right? This bond will be break. This CO bond will be break, and one hydrogen come. Okay, one hydrogen will come and make bond with this carbon, and the second hydrogen will come and make bond with this oxygen, right? So आपने क्या करना है? You have to just add the hydrogen to this carbon and other hydrogen to this oxygen. Okay, and just break this pi bond. Okay, so what you will get? So you will get this C, right? And this bond will be break. So here O and this hydrogen, right? And here the hydrogen, other hydrogen. Okay, so this is your alcohol. What is it? This is your alcohol, this CH3OH. Okay, और आप इसे कैसे लिख सकते हो? It's CH3OH. This is your methanol. Okay, so alcohol, it will reduce to alcohol. Got my point?
Yes, ma'am.
Yes or no? Yeah. So reduction of aldehyde and ketone will give you a corresponding alcohol, right? So just what you are supposed to do, just this bond will be break. Just a second. The CO bond, just न्यू बॉन्ड को आपने क्या करना है? ब्रेक करना है, right? And new bond will be formed, right? Which CH bond and OH bond. These two new bond will be formed simultaneously, right? Means you have to add addition of hydrogen. Okay, so it will lead to the reduction. It will lead to the reduction because you are using the reducing agent. So this reducing agent will reduce this CO group. Okay, CO group to the corresponding alcohol. See, one more thing. The number of carbon will be same. Okay, आपने number of carbon में कोई alternation नहीं करनी, right? The number of carbon will be same. What you're supposed to do, just add two hydrogen. Okay, add the hydrogen and it will get reduced to the corresponding alcohol, right? See, so aldehyde and ketone can be easily converted to alcohol using suitable reducing agent. Okay, now the question is, which reagent we can use as a reducing agent? Okay, so first one, H2. You can use the H2 in the presence of any catalyst like your nickel or palladium or platinum. Okay, H2 hydrogen in the presence of either nickel or palladium or platinum. Okay, so this is also known as catalytic hydrogenation. Hydrogenation कराना है आपने in the presence of a catalyst. So these nickel, palladium, and platinum, they will act as a catalyst. They will provide a surface area for the reaction, right? So first one, which reducing agent you can use? So this H2 in the presence of any catalyst like nickel, palladium, or platinum. Okay, so first step, catalytic hydrogenation kara do. So it will reduce the a carbonyl group will be reduced to the corresponding alcohol. Yeah. Second step. Second, you can use a strong reducing agent, which is a lithium aluminium hydride. Okay, so lithium aluminium hydride is a strong reducing agent as compared to the sodium borohydride. Now, how? How? So, see, lithium, lithium, and aluminium hydride, LiAlH, and here the sodium NaBH. So you can see here the aluminium is present. In lithium aluminum hydride, aluminium is present, and in sodium borohydride, boron is present. Now tell me which one is more electronegative. Which one is more electronegative?
Lithium, aluminum, hydride.
Lithium or boron? lithium or boron, between these two, which one is more electronegative? Okay, see. So here in lithium aluminum hydride, what's the bond? So here the aluminium and hydrogen bond is present, right? And aluminium, this is less electronegative as compared to the boron, right? So due to the less electronegativity, what this aluminium and hydrogen bond is more polar, right? This bond is more polar. So due to the more polarity, this is a, you can write, this is a strong reducing agent. It will reduce any group. Either it's a ester or carboxylic acid, because see, in carboxylic acid, the two oxygen is present. Okay, and what is reduction? Reduction is the either removal of oxygen or the addition of hydrogen, right? So when you reduce this carboxylic acid, and if you are not using the strong reducing agent, if you are using the sodium borohydride, so it's not as strong as compared to the lithium aluminum hydride. Okay, so weak reducing agent होता है. So here two oxygen is present, right? So here more oxidizing, strong reducing agent will be required. Why? To remove these two oxygen, right? Because two oxygen is present and reduction karana means you have to remove this oxygen. Okay, the removal of oxygen is known as a reduction, right? So that's why the sodium borohydride don't reduce this carboxylic acid. It only reduces the aldehyde and ketones. Aldehyde and ketones. But lithium aluminum hydride is strongest reducing agent. It can reduce any group. Okay, whether it's a carboxylic acid, ester, your carbonyl compound, any group. Okay, so these 2 points, just keep this in your mind. It's very important. Any doubt in this?
No, ma'am.
Okay. Yeah, so you can use either, you can do the catalytic hydrogenation. Okay, use hydrogen H2 in the presence of any catalyst. Second, use a lithium aluminum hydride. It will reduce any group. Okay. Third one, just use the sodium borohydride. It will only reduce a carbonyl compound. Okay, ketone and aldehyde. Fourth one, you can also use sodium in the presence of ethanol. Sodium in the presence of ethanol. Okay, so Na in the presence of C2H5OH. Okay, now let's do some questions. Or suppose this is your RCHO group. So RCHO group is your aldehyde. CHO group क्या होता है आपका? Aldehyde होता है. So we are reducing the aldehyde. Okay, so if you are using the reducing agent, what will happen over here? Again, do the same thing. Two hydrogen we have to add. You just break this bond, break this CO bond, add one hydrogen to this carbon and the other hydrogen to this oxygen. Now write down the, so you will get this H group over here, H group over here, single bond, because this pi bond will be break, and this H. Okay, so it will give you a corresponding alcohol. Now just rearrange the hydrogen. So it will give you R, C, and to this C, how many hydrogens are there? Two hydrogen, RCH2OH. Okay, so this is your primary alcohol. When you reduce the aldehyde group, okay, so the on reduction of aldehyde group, it will give you a primary alcohol. It will give you primary alcohol. This is your primary alcohol. Is it clear?
Yes, ma'am.
Okay. Now, second one. Now see, this is if I attach the other alkyl group over here. So this is your RCO. This is your RCO R dash. So which group it is? It's a ketone. Okay, so on the reduction of ketone, so what you're supposed to do, just again do the same thing. Just break this pi bond, add one hydrogen to this carbon and the other hydrogen to this oxygen. Now write down this R. Okay, this R dash. Here the hydrogen, single bond, and this switch. Okay, now you can rearrange this. So this is your R group. This is your CH group. You can write CH and OH, right? And this is your R group and your R dash group. Now tell me, what is the degree of this alcohol? Which alcohol it is? Primary, secondary, or tertiary?
Secondary.
Yes. So the reduction of ketone will give you a secondary alcohol. Just remember that. Okay. But the reduction of aldehyde will give you a primary alcohol. Okay. It will give you secondary alcohol. Okay. So here's the point. These important points, just write it down. Aldehyde gives primary alcohol on reduction. Okay. Ketone gives secondary alcohol on reduction. And the number of carbon atom remains same. Okay. Number of carbon atom should be same. Okay. Write down. Yeah. Okay. In the notes part, write down these. What I explained it to you. Like lithium aluminium hydride is more stronger reducing agent than your sodium borohydride. Why? What's the reason? So because aluminium in lithium aluminium hydride, aluminium is less electronegative than the boron. Okay. So this bond, aluminium and hydrogen bond in lithium aluminium hydride is more polar. Why it's more polar? Due to the less electronegativity difference between the aluminium and hydrogen, right? So therefore, thereby making the lithium aluminium hydride a strong reducing agent. Okay, the bond between the aluminium and hydrogen will be more strong as compared to the bond between the boron and hydrogen, right? Because boron is more electronegative, right? So it will just it has a tendency to pull electrons towards itself, right? So the bond here in the case of boron and hydrogen will be weak as compared to the aluminum and hydrogen, right? So that's why your sodium borohydride is weak reducing agent as compared to the lithium aluminum. Okay, so lithium aluminum hydride will reduce every group, everyone, but your sodium borohydride will reduce only your carbonyl compounds, which is your aldehydes and or ketone group. Okay, and yeah, this point is again very important. And yeah, catalytic hydrogenation. If you do the catalytic hydrogenation of your carboxylic acid, okay, so again, the catalytic hydrogenation and sodium borohydride will not convert this carboxylic acid to alcohol. Okay, सिर्फ क्या करेगा lithium aluminum hydride you can use to reduce the carboxylic acid to the corresponding alcohol. Okay, so just remember this point. This point is important. Sodium borohydride as well as your catalytic hydrogenation. Okay, catalytic hydrogenation से भी आप carboxylic acid को convert नहीं कर सकते corresponding alcohol में. Just keep this in your mind. Okay, now write down this point. Have written everyone?
Yes, ma'am.
Okay. Okay, so here's a question. Write a major product of the following. Okay, just quickly do that. It's very easy. What you're supposed to do, just reduce the number of carbon should be same. Okay, so just reduce that aldehyde, whether it's a ketone, carboxylic acid, accordingly. Okay, just keep this in your mind that H2, this catalytic hydrogenation and sodium borohydride will not reduce the carboxylic acid. Okay, keeping this in mind, just do that. Just do this. I will ask.
Ma'am,
Yes.
for the fourth one, under the arrow, what is it written?
Ethanol, ETOH. This is your ethanol, C2H5OH. Okay, you can also write this ethanol as ETOH. Okay, ethanol, ethyl alcohol. ET for ethyl and OH for alcohol. One more question is ninth. And then okay, yes, Jupiter, tell me the first one. What could be the product here? Yes, Jupiter. Catalytic hydrogenation of your propanol will give you which product? Jupiter.
Yes, ma'am. I was not completed that, sir. I was doing.
Okay, do the first one. First one, what will be the, how you will reduce this aldehyde group? Okay, next, Anisa, tell me, what is the product?
Ma'am, CH3, CH2, CH2OH.
CH3, CH2, CH2OH. Yeah, good. Okay, so it will give you
Primary alcohol.
propanol. Yeah, propanol. Okay. Okay, second one. Yes, Muniva, tell me the second one.
CH3CH
Yes.
and like above it CH2OH,
Okay, very good. And here CH.
CH3.
Good. Okay, now Aisha, third one, on reduction of this compound, what will be the product? Yes. Oh, she is frequently. Yeah, Jubita, tell me the third one.
CH3, CHOH, CH3.
CH3, CH, CH3, and
No, ma'am, OH,
OH.
CH,
OH on which carbon you will attach the OH?
third one. Second carbon.
Yes. CH3, CH, OH, and CH. Right. So the on reduction of ketone, you will get a secondary alcohol. Right. So this is your secondary alcohol. Very good. Yeah, the fourth one, Anisa. Sodium in the presence of your ethanol. Again, you will do the reduction. And here the carbonyl comes. This is your CO group, ketone group. So ketone group will be reduced to corresponding alcohol, right? So what will be with the product here? OH. You will attach OH over here. And just break the bond, CO bond, and attach one hydrogen over here and one hydrogen over here, right? So you will get this. Okay,
Okay.
fifth one. Fifth one. Yes, Manima, fifth one.
In place of CHO, it's CH2OH.
Yes, you will get this. Okay, so 1, 2, 3, 4. So this was the butanol. So butanol will be reduced to the butanol. Okay. Sixth one, Jubita. Why is taking too much time? It's very easy. See, so this is a ketone group over here. Right? So ketone group will be reduced to the corresponding alcohol, right? Because H2 in the case of platinum, it will reduce this ketone. Okay, and this ketone, आपको क्या करना है? This CO group के जगह पे you have to attach this OH. Okay, just convert this CO group to OH group. That's very easy. Seventh one. Yes, Anisa. Anisa, seventh one. When you put the lithium aluminum hydride in this, so what will be the product? Yes, Anisa. Okay, no problem. Just tell me. You're not sure, but just tell me the answer. This is a CHO group, right? Aldehyde group. So this aldehyde group will be converted to the corresponding alcohol. What you're supposed to do, this group as it is, okay, cyclopentane ring as it is, and on this place, this is your CHO group. This group, CO and H group. Okay, just break this bond. Just break this bond. Attach one hydrogen over here and one hydrogen over here. Right? What I said. This bond will be break and one hydrogen आपने oxygen पे attach करना and one hydrogen attach over here. So it will give you CH2OH. Right? So it will give you, this is your CH2OH. So CHO will be converted into CH2OH. Okay?
Yes, ma'am.
Yeah. Yes, Maniva, next one. See, suppose this is your first carbon, this is your second carbon. Okay, now tell me which carbon will be reduced to which group?
The
Yes.
first carbon will reduce to CH2OH.
Yeah, very good. And the second carbon? OH.
It won't.
Yes. Okay. And here you can just attach it. Okay, and also you can also draw it like carbon pop as a sector 1, 2, 3, 4, and this 5 carbon, and here the OH group, right? This is the fifth carbon, and this is the OH group, and here this ketone. Okay, next one. Yes, Jupiter. Jupiter and Aisha Salim. Anyone know the answer? Suppose this is the first carbon, right? This is the second carbon, right? So tell me which carbon will be reduced to which group? We are using sodium borohydride, and you know very well sodium borohydride will reduce a carbonyl compound, means aldehyde as well as ketone, right? So this is ketone CO group. Okay, first आपको identify करने आना चाहिए which group is present in this molecule. This is a ketone CO group. So CO group will be reduced to alcohol. What you're supposed to do, this is your CO bond. This is your CO bond. Okay, simple mechanism मैंने पहले समझा दिया. What you're supposed to do, just break this bond, break this CO bond, okay, and attach one hydrogen on this oxygen and one other hydrogen with this carbon. So you will get CHOH, right? So what you're supposed to do, just attach OH over here, right? So this on this oxygen, hydrogen will be attached, right? Hydrogen will be attached. Now again, this, what about this CHO group? So CHO group will be reduced to CH2OH. Okay, again move karoge aap same thing. This is your CHO group. This is your CHO group. Okay, what you're supposed to do, just break this CO bond. You are supposed to break this CO bond and one hydrogen will come over here and one hydrogen will come over. So it will give you CH2OH. Okay, CH2OH. That's the product. Clear to everyone?
Yes.
Okay. If there is any doubt, you can ask. I think Jubita, Anisa, and Aisha, you guys have little bit confusion in this. If there is any doubt, just ask me now. Yes? Is it clear, bacho?
Yes.
Next, reaction with Grignard reagent. Okay, so that's again the reaction of carbonyl compound. First was the reduction of carbonyl compound. Okay, so the reduction of carbonyl compound will give you a corresponding alcohol. Okay, aldehyde will reduce to a primary alcohol and the ketone will reduce to the secondary alcohol, right? But here, the reaction with Grignard reagent. Now, what is Grignard reagent? So this is your Grignard, RMGX is known as when you use a magnesium metal, okay, halide, okay, magnesium halide along with your alkyl. So this RMGX is your Grignard reagent, Okay, this is a Grignard reagent. Now see, अभी तक हम क्या कर रहे थे, like your RCl bond, alkyl halide, your alcohol. Okay, each and every bond when we talk about, so this is more electronegative, so it will acquire partial negative charge, and this alkyl group have partial positive charge. Right? अभी तक जितने भी हमने bonds देखे, so alkyl group have partial positive charge. Again, this alcohol also. So alcohol has partial negative charge, right? This OH bond, and this R group will have partial positive charge. But in the case of Grignard reagent, because here the metal is attached, right? So metal is electropositive. Metal का क्या होता है nature? It's electropositive. So due to the electropositive nature, this metal will attain partial positive charge. Okay, and if this metal attains a partial positive charge, this alkyl group will have the partial negative charge. Okay, so in Grignard reagent पे बिल्कुल opposite होता है due to the presence of a electropositive metal, which is magnesium. So magnesium, whenever there is a metal attached to the alkyl group, okay, so alkyl will attain the partial negative charge, and the metal will acquire the partial positive charge. Just remember this. Is it clear?
Yes, ma'am.
Okay. Now just try to understand this mechanism. What happens here? So reaction of carbonyl compound with the Grignard reagent. So how this carbonyl compound? So this is a carbonyl compound CO group. Okay. If I attach, suppose here the R group and here the H group, so it will become your aldehyde. And if I attach the R dash group, another R group here, so this will become your ketone group. Okay, CO group, R, CO, R dash. Okay, alkyl group. Okay, and if I attach the hydrogen over here, so it will become RCHO group, which is your aldehyde. So generally, we are talking about the carbonyl group, carbonyl compound. So when carbonyl compounds react with RMGX, so you know very well this R will have partial negative charge, right? And this magnesium, this whole group, MgX, will have the partial positive charge. Okay, and what happens here? This bond, this CO bond. Okay, so just tell me which one is more electronegative, carbon and oxygen. Between the carbon and oxygen, which one is more electronegative? Anyone? Which one is more electronegative, carbon or oxygen?
Oxygen.
Yeah, it's oxygen. So due to the more electronegative nature, the oxygen will acquire partial negative charge, right? And this carbon will acquire partial positive charge. Okay, so that's the trick. This is very important to differentiate which one will acquire partial positive charge or negative charge. Because the opposite will attract, see, this R group has a negative charge over it, right? So what will happen? This alkyl group will attach to this carbon. Why? Because this carbon is positive, electropositive. And you know very well, okay, unlike charges attract each other, right? Unlike charges attract each other. So that's why this is negative. Alkyl group is negatively charged over here. And so it will attach this carbon. ये कहाँ पे attach होगा? This carbon. Okay. Now, what will be the, if this attach here, so this bond will be shift here. Now, what will happen? Now, this CO, okay, and R को यहाँ पे attach कर दो. Next one, this bond will be break over here, and it will minus charge. And because this oxygen is negatively charged, so this positive part of this reagent will attach to this negative part. So MgX. Okay, O minus and plus MgX. Is this a step clear to everyone?
Yes, ma'am.
Yuvita, Anisa, and Aisha?
Yes,
Yes,
ma'am.
ma'am.
So this O minus and MgX. Now, when you do the hydration, H2O, when you put the water in it, okay, what happens over it? Because this H2O will dissociate to form H plus and OH minus ion, right? तो इसके पास क्या है H plus and OH minus ion. Now it's very simple. H plus कहाँ पे जाएगा? H plus will attach to this oxygen, right? And Mg के साथ, MgX के साथ, the OH minus will be attached. Okay, so positive, negative, and then negative, positive. Okay, just like that. Just make the bond, this R group as it is. And here, OH. The alcohol will be formed, plus the byproduct will be MgOHX. Okay, MgOHX. Okay, so that's the whole mechanism of how the reaction occurs. And when you react the carbonyl compound with the Grignard reagent, so again you will get a corresponding alcohol. That's the alcohol. Okay, and you can also write it as R. This is your R. Okay, this is your C. Okay, this is your 2 hydrogen bond, RCH2OH plus this. Is it clear?
Yes, ma'am.
Okay. So what you're supposed to do, just remember, this is a two-step mechanism. Okay, first step में क्या करना है आपने? Just react it with the Grignard reagent. Okay, so if you attach it with, react it with Grignard reagent, so this R part, because this is a negative, so it will attach to this carbon. Okay, the positive carbon. And this oxygen is negative, so the positive part of this Grignard reagent, which is MgX, will attach over here, right? Now this O minus and MgX plus. But in the second step, just add the water, okay, to the hydration. And what happens? This H plus, this water has H plus and OH minus ion, so H plus will attach to this oxygen, and to this MgX, OH minus will be attached. Okay, and you will get a corresponding alcohol. Okay, just break this CO bond. Okay, CO bond का ये आप pi bond break कर देना है, double bond, and new bond will be formed between the carbon and R group. Okay, this carbon and R group, this is a new bond, and simultaneously OH bond will be formed. These two new bond will be formed, and this old bond, which is pi bond, will be break. Okay, so that's how the reaction proceed, and you will get a alcohol. Yeah. Now, one by one, we will see with different aldehyde and ketone, what will be the reaction when you treat the carbonyl compound, or like your aldehyde, your uh, basic aldehyde, like your formaldehyde and others aldehyde and your ketone. So what will be the product in this case? Whether you will get primary alcohol, secondary alcohol, tertiary alcohol. So let's see one by one. Now tell me, what is the structure? What's the name of this compound? What is the name of this compound? This is your basically HCH. इसे हम क्या कहते हैं? Commonly HCHO को what we call as? Okay, जिसे भी पता है just tell me.
Methanol.
Methanol, methanol.
Yeah. Any.
Yeah, it's methanol, and commonly we call it as a formaldehyde. It's a formaldehyde. The simplest aldehyde is your formaldehyde. What is this? HCHO is your formaldehyde. Okay, the next, suppose this is your HCHO. This is a formaldehyde. Now, instead of H, when I attach R group, RCHO. Okay, RCHO. So this is your other aldehyde. Any other aldehyde means इसे छोड़ के formaldehyde, other than formaldehyde. So you can write other aldehydes. You can write. Okay, other aldehydes. Okay, second one, if I remove this hydrogen, okay, if I replace this hydrogen by other alkyl group, any other alkyl group, so what is this? What is this compound? So it's a R dash, RCOR dash. So what is this? This is a ketone. This is a ketone. Okay, so one by one we will see when we react this formaldehyde with your Grignard reagent, what will be the product? Okay, same mechanism we will follow. What we are supposed to do? Again, the two-step mechanism. First, you will react with this formaldehyde and other aldehydes and ketone with the RMGX. Okay, RMGX, and X could be or anything. Okay, either chlorine, bromine, anything, which we are place सकते हो. Okay, and in the second step, do the hydration. So you will get a corresponding alcohol. Okay, corresponding alcohol. So just remember the mechanism. What you are supposed to do, just break the CO bond. Okay, CO bond का आपने pi bond break करना है, and this R group को किससे attach कराना, carbon से, and the hydrogen will attach to the oxygen, right? Hydrogen will attach to the oxygen, and the R group will be attached to the carbon. Okay, these steps, just remember that. Okay, now let's see one by one. First, write down when RMGX plus formaldehyde. Okay, your Grignard reagent plus formaldehyde, so it will give you primary alcohol. Okay, when you treat the formaldehyde, HCHO, plus your Grignard reagent, so what will be the product? So product will be your primary alcohol. Okay, see the reaction. This is a HCHO. Okay, and first step will be RMGX. Okay, and second step में क्या करोगे? Do the hydration. Okay, so you will get a corresponding alcohol. This is your RCH2OH. RCH2OH. Now let's see what will be the mechanism. You can easily do the mechanism. Mechanism, as I told you, what you are supposed to do, just break the CO bond, okay, and attach the R group to the carbon and the hydrogen to the oxygen. Okay, let's see the mechanism here. If we take HCHO, suppose this, okay. So when you treat, first step will be, you will treat this with RMGX. Okay, so this MGX will have partial positive charge, and this R group will have the partial negative charge. Okay, partial positive and partial negative charge. Between this carbon and oxygen, this oxygen will have the negative charge, and this carbon has a positive charge. Okay, just attach this R group to this carbon, and this bond will shift over, right? So here H, C, H, and here the R group. And यहाँ पे क्या होगा, oxygen पे minus charge, and this whole group MgX positive, this group will attach over here, MgX, right? This is a positive. Now in the second step, when you do the hydration, H2O, so H2O will give you H plus and OH minus ion, right? H plus will goes with the oxygen, and OH minus will goes with the MgX. Okay, so you will get H, C, H, R over here, and here OH plus MgOH. That's the whole mechanism. Okay, और आप इसे कैसे लिख सकते हो? This is your R. Okay, R group. To this carbon, there are two hydrogen attached. Okay, so CH2 and OH. So it will give you, this is your primary alcohol. This is your primary alcohol. That's the whole mechanism. Okay, when you react the formaldehyde to the Grignard reagent, so it will give you a primary alcohol. Just remember that. Is it clear?
Yes, ma'am.
Anisa, Jibita, Aisha?
Yes, ma'am.
Yes, ma'am.
Okay, write down the mechanism. Okay, and second and third के लिए भी आप same mechanism follow करो. Do it by yourself. Okay, write down in your homework. Just write down the whole mechanism and how this secondary alcohol came. You have to show that. Okay, using the whole mechanism. Now see the second one. When your other aldehydes, means other than formaldehyde. Okay, other than formaldehyde means we are using this R in the place of H. Okay, one H, you just replace the R group, any alkyl. So this is your other aldehyde. So other aldehyde ko, when you treat it with the Grignard reagent, you will get a secondary alcohol. You will get a which alcohol? Secondary alcohol. Okay, and easily you can do the same thing. Just do the mechanism, whole mechanism step by step, and you will see that it will give a secondary alcohol, right? So first step again, when you treat it with R dash MGX. Now why I written over here R dash, because this is your R group. Okay, So confusion यहाँ पे create ना हो, इसलिए that's why I have just put this R dash. Okay. So this R dash will have the negative charge and this MgX will have the positive charge, right? Between this carbon and oxygen, this will have the carbon has a positive charge, right? So this R group will come and it will attach on this carbon, right? Now, so it will give you R, C, R dash, OH over here and H over here. Okay, and to this oxygen, यहाँ पे oxygen पे क्या होगा? This bond will be break, and to this oxygen, your hydro H plus, right? Because this H2O will give you H plus and OH minus in the second step, right? Second step में क्या कराओगे? This H plus will come and attach this oxygen, and it will give you a secondary alcohol. Yeah. Similarly, when you can do the whole mechanism. First step, just treat it with R dash MgX. Okay, Grignard reagent. So it will give you something. This compound R C H, and here the negative charge, and here R dash. Okay, and here the positive. आपकी positive part Grignard reagent का you have to attach over. Okay, this is the first step product. Second step, when you do the hydration, so H plus and OH minus it will give. So H plus will come and attach on the oxygen, and this will come with this. Okay, well, it will give you this R dash and here CH, OH. Okay. Your secondary alcohol. Got my point? Similarly, see the third one. When RMGX, when you treat it with ketone, जब आप कीटोन के साथ इसका ट्रीटमेंट कराते हो, so it will give you a tertiary alcohol. Okay, so it will give you a tertiary alcohol. Okay, let's see the whole mechanism. Okay, see the third reaction. RMGX plus ketone. Suppose we just take the ketone. This is your R, this is your CO, and this is your any other alkyl group R dash, right? When you treat it with RMGX, okay, suppose we just take it as R1, right? This is a R1, any other alkyl group. So यहाँ पे confusion create, no, that's why I just write R2MGX, any second alkyl group, okay? So that this is R1, and this is R. So first step will be just this will acquire this alkyl group. R2 will acquire partial negative charge, and this will acquire partial positive charge. Between this carbon and oxygen bond, this carbon has partially positive charge, and this will have the partial negative charge, right? So this R2 will come and attack this carbon, which has a positive charge, right? Now, क्या compound बनेगा आपका? This R, C, R1, okay, and here you will attach the R2, this R2, okay, and here oxygen P, there will be negative charge, and to this negative charge, this positive part of the reagent, your Grignard reagent, will attach over here, right? That's the first step. Second step, okay, when you hydration कराओगे आप H2O से treat कराओगे, so it will give you H plus and OH. Okay, so H plus will come and attach this oxygen, and OH minus will come and attach this MgX. So what will be the product in this case? R carbon, this R1, this is your R2, and here OH will be. So now you can see this is the hydroxyl group is attached to this carbon, and this carbon is further attached to three different groups. Okay, so this is a tertiary alcohol. So it will give you a tertiary alcohol. So on the treatment of ketone, okay, when ketone is treated with the Grignard reagent, it will give you a tertiary alcohol. plus what will be the byproduct? MgOH. Is it clear now?
Yes, ma'am.
Okay. Why others are not responding? Anisa, Jibita, Aisha, आप लोगों को समझ नहीं आया?
Yes, ma'am.
Understood,
Aisha,
ma'am.
Aisha, बच्चे, why are you not responding? Is it clear? Aisha, okay. Okay, do these questions now. Write the products of the following. R can be anything, right? So in the first case, the R group, alkyl group is a CH3, right? So just attach the CH3 group to the carbon of the formaldehyde. Same mechanism, step by step. If you follow the step by step rule, so it will be very clear and you will get the proper correct answer, right? So just a step by step mechanism follow. Can everyone?
Yes, ma'am.
Okay. Yes, Jivita, first answer. What will be the product, Jivita?
I just wrote the questions right answer.
Okay. Anisa, have you done the first one?
Yes, ma'am.
Okay. Tell me the
C
answer.
CH2OH. CH3 CH2OH.
Yes. Good. CH3, CH2OH. Oh, very good. Okay. The second one, Muniba.
CH3, CH2, CH2OH.
Yes. Yes, Aisha, third one. No? Okay, this group, CH3, CH2, and CH3 group is your alkyl group. Okay, so just attach this alkyl group to this carbon. Okay, when you attach this group to this carbon, so it will be CH, okay, and 1, 2, 3. Basically, this group, this is your CH2OH. Okay, this aldehyde CHO will be converted to CH2OH, and this group attached कर देना आपने इस carbon पे. So it will be CH. This is your CH. This part. First carbon. Suppose this is the first carbon, second carbon, third carbon. So second carbon. This is the second carbon CH group. First carbon, 2-methyl group is attached. CH3 and here the C. Okay, so that's your product. That's your product. 1, 2, 3. Okay. Fourth one. Yes, Jupiter. Fourth one.
CS3, CS2, CH, CS2, CS3. OH group.
CH3, CH2. After that,
OH group.
here CH2,
Yeah.
CH3, right? And here OH will be attached, right? So you will attach on the second carbon, you will attach the CH3, CH2, right? Suppose this is the first carbon, this is the second carbon, right? So this CO bond will be break, and this will carbon has a partial positive charge, and this will have the negative charge, right? So this O के साथ आपने क्या attach कर देना hydrogen, so it will give you CH2OH, right? And here this carbon you will attach this alkyl group, which is CH3, CH2. Okay, so CH2, CH3, I have attached it over here, and here the OH. Clear to everyone?
Yes, ma'am.
Okay, fifth one. Who will tell me the fifth answer? Again, it's very simple. This is a alkyl, right? So this alkyl group will have the negative charge, right? This carbon to this carbon, there will be a negative charge, and this whole group will have the partial positive charge. This carbon has the partial positive charge, this will have the negative charge, right? So what you are supposed to do, this carbon just attach it over here. इस carbon को क्या आपने करना है? Attach it over here. So what will be the product? This is your alkyl group, which is attached to this carbon, right? This carbon, and here we will attach the hydrogen. This CO bond आपने क्या करना है? Just break this CO bond and attach this hydrogen to this oxygen. That's the product. Any doubt in this? First, identify the R group. This is your RMGX, right? So what is R group over here? R group is your cyclopentane. Cyclopentane. So this cyclopentane, to this carbon of the cyclopentane, there will be a partial negative charge. So this पे negative charge होगा, वहां से आपने attach कराना, right? So you will attach this carbon to which carbon? So this carbon, right? This carbon, the CO group carbon. Okay, after that, you will get this, and this oxygen will have the negative charge. So when you do the hydration, so H plus ion come and attach to this oxygen, and it will give you a corresponding atom. Is it clear?
Yes, ma'am.
Okay. Now do the sixth one. This is oxygen, double bond oxygen. See. Okay, do this question. Again, it's very simple. See, this suppose this is the first carbon, first carbon, second carbon, third carbon. This is your alkyl group. Okay, this alkyl group को आपने attach कराना है to this carbon, right? Now, what will happen over here? Because this will have the negative charge. The second carbon will have the negative charge. So you will attach this carbon, the CO carbon. यहाँ से आपने attach कराना है to the second carbon. Yeah, this second carbon will attach to this carbon. So what will be the product in this case? Just break the CO bond. This bond will be break, and this will have the partial positive charge. So this negative part will come and just attach over here. So this is your 1, 2, 3, three carbon chain. Okay, so iso group 1, 2, 3. First carbon, right? And this iso group. And here the oxygen is present, so this bond will be break. And to this oxygen, the second step, protonation will be done. Okay, hydrogen will come and attach over here. So this will be your final answer. Is it clear?
Yes, ma'am.
Okay. So you have to attach that carbon which has a negative charge, right? After first, second, see, this is the first carbon, second carbon, third carbon. So when this bond will break, so the negative charge, partial negative charge will be on the second carbon. So you have to attach this group by the second carbon. यहाँ second से आपने attachment कराना है to this. Okay, this group will come and attach to this carbon, and you will get this product. Okay, write it down. Done? Okay, now see. Here's a question, convert the ethyl bromide to propanol. How you will convert the ethyl bromide to propanol? Anyone? How we can convert the ethyl bromide to propanol, which is alkyl halide to alcohol? कैसे कर सकते हैं? Either by the nucleophilic substitution reaction. You can do the nucleophilic substitution reaction, right? SN2 mechanism. So if we see, if we treat it with sodium, aqueous sodium hydroxide, what happens over here? Just a second. Yeah. So by the nucleophilic, when you do the bimolecular nucleophilic substitution reaction, so you will treat it with So aqueous potassium hydroxide or aqueous sodium hydroxide, right? So here from here, what will be the nucleophile? So nucleophile will be OH minus, right? So OH minus will come and attack this carbon, this alkyl group, and bromine is a good living group, so just it left. Okay, so it follow the SN2 mechanism and you will get this propanol. Okay, you will get this propanol in this case. Just a second, not the propanol. See one more thing. If you are just thinking that you can do the nucleophilic substitution reaction and you can prepare it by a uh, nucleophilic substitution reaction, so it's wrong. You can see you have to prepare the ethyl bromide to propanol. Okay, means the here the increment of one carbon has been done. Okay, यहाँ पे कार्बन का एडिशन हो रहा है, राइट? इथाइल ब्रोमाइड 2 कार्बन से 3 कार्बन में कन्वर्ट हो रहा है. So when you do the nucleophilic substitution reaction over here, so you will get the ethanol, not the propanol, right? Now the question is, so how we can prepare the ethyl bromide to propanol? Because by this method you can't prepare the ethyl bromide to propanol. Okay, so that's the wrong method. See, so we have to prepare the ethyl bromide to propanol. Means हमें one carbon का addition करना है. So we can prepare it by first you can convert. If you add this, आपने इसे magnesium से treat करा दिया. Addition of magnesium will give you a Grignard reagent. Okay, Grignard reagent MgBr. First step will be when you add addition of magnesium, okay, metal. When you treat the alkyl halide with a magnesium metal, so it will give you a Grignard reagent. It will form a Grignard reagent MgBr. After that, because we have to increase one carbon, so what we are supposed to do, we can treat it with again. हम क्या करेंगे इसे formaldehyde के साथ treat करा दें HCH. Okay, because we only need one carbon. We only need one addition of one carbon. So 2 carbon is present over here in this your Grignard reagent, alkyl group, and we have to increase only one carbon. So that's why we have been used formaldehyde. हम formaldehyde के साथ अगर इसका treatment करा देते हैं, and in the second step we can do the hydration. Okay, so you will follow the same mechanism. So this is HC HO. Okay, this is a formaldehyde. When you treat it with this MgBr, what you are supposed to do? This will have the partial negative charge and this will have the partial positive charge, right? And between this formaldehyde में this CO group, so this between the CO groups, carbon has a partial positive charge and this will have the negative charge. Okay, so what will happen in this case? HC, okay, and this group will come and join over here, this 2 ethyl group. Okay, C2H5 आप लिख सकते हो, or you can use CH2CH3 group, right? And here OH group and here the hydrogen. Okay, so it will give you, now you can see it will give you this CH3, CH2, CH2OH, which is a propanol, right? So how we can convert the ethyl bromide to propanol? So first step will be the just treat it with the magnesium reaction with magnesium. It will give you a Grignard reagent. And once you just get the Grignard reagent, just add formaldehyde. Formaldehyde से आप treatment करा दो. And second step में क्या करो? Protonation बोल सकते हो, आप hydration बोल सकते हो. Do the hydration and you will get the propanol. Is it clear?
Yes, ma'am.
Clear to everyone? Yeah.
Yes, ma'am.
Yeah, so don't think that you can prepare it very easily, like when you do the nucleophilic substitution reaction. So here in the nucleophilic substitution reaction, the number of carbon should be same, right? It won't increase. But in the conversion, the question is we have to convert the 2 carbon, which is ethyl bromide, to the propanol, which is 3 carbon, right? So हमें addition कराना होगा 1 carbon का, so that we just follow this rule. Okay, this mechanism is wrong. We will not follow this SN2 mechanics. Okay, write it down. And
Yes.
okay. So the next preparative method is from the carboxylic acid. But I think the time is up, so I stop it over here. So two method of preparation has been left. First one is your bicarboxylic acid, how we can prepare the alcohol, and the second is from the amines. After that, we will do the methods of preparation of phenols. Aliphatic primary amine. Okay, so total preparative method is six. Six preparative methods are in your syllabus. And for the phenol, there are, I think, 3 to 4 is enough. Okay, so that's all for today. If there's any doubt in today's session, please ask me.